Oh, this is a pretty cool question. We're deriving this function. It has two variables, and we're deriving it with respect to x and y, and each derivative is going to be significantly different than the other. So the first one, fx, is the same as the derivative of the derivative of f with respect to x. So that means we're taking this expression there for x, 7y, and we're deriving this with respect to x. Now, because when we're deriving with respect to x, we pretend y is a constant, so we are assuming this is just a constant. How would we derive that if that were, say, an x cubed or something, right? If this power were just a 3 or something like that. We bring the power down, the 3, and subtract 1 from the power. That's exactly what we'll do here. We'll use the power rule. So by the power rule, because y is a constant right now, we have 7y, right? The power comes down. Now we do. So let me organize it better. 4 stays, and then 7y comes down, x2, 7y minus 1. Right, so this is what? This 4 did not change because it's a constant. I can pull it out of the derivative. Now when I derive this, the result is that. So that is what I have. Maybe I can just multiply the 7 by the 4 to get a 28y x 7y minus 1. And that is the derivative with respect to x. Now when I derive it with respect to y, it will be slightly different. This is the derivative of f with respect to y. So this is d dy of 4x 7y. So now I'm deriving out. I'll bring out the 4 first, because that was a little confusing last time. So I'll first bring out the 4, since it is a constant. And now I'll derive this thing with respect to y. Now y is not a constant, x is. So it's as if I'm deriving something like 2 to the 7y. So something like that. I'm pretending that x is a constant during this derivative. So how do I deal with that? So the best way to deal with this type of problem is to rewrite the power, or x, as e to the ln x. Note that e to the ln x equals to x. So that means this is 4 d dy e to the ln x, but then since that's further raised to the 7y power, it's the same as multiplying that here. So now I'm deriving an exponential function, e to some power. The derivative of e to the u is just e to the u again, times the derivative of u, which is the exponent. So the derivative of the top, remembering that y is the only variable and the rest is a constant. The derivative is just a constant multiplying y. So that's just ln x 7. So that is just the chain rule for me. So I'm using the derivative of the exponential function plus the chain rule. The chain rule. All of that together. A couple of things to notice. This guy, right? Note that I rewrote this guy here as that. So could very well write it back as what it was. X to the 7y times then 7 ln x. So I could put the 7 again and the y together, or and the 4 together, excuse me. So 28 x to the 7y ln x is as good as a result as I'm going to get.